Hello and welcome to the Math Studio. In this video, we're going to look at another interesting example involving the conversion of parametric equations into Cartesian form. However, there's an alternative method of answering a question like this or something similar to this. So let's have a look at this example. Then you can decide whether conversion into Cartesian form is appropriate or is there another way that we can in fact tackle this example. So let's have a look at it. Find the gradient and y-intercept of the line described by the parametric equations x equals 2t plus 1 and y equals 5t minus 3. Now, of course, we can convert that into Cartesian form by making t the subject of the formula in equation number 1. In fact, what I might do is I might just label these equations first to make it easier to refer to. So we could make t the subject of the formula in equation 1 and substitute that into equation number 2, thereby eliminating the t, and then we have an equation in the form y equals mx plus c, and then we can read the gradient and the y-intercept from that equation. Is there another way that we could look at that? Yes, and I'm going to just quickly highlight that way first. What we could do is to come up with two coordinates by choosing two values of t. So if we let t equals 0, we have x equals 1 and y equals negative 3. So that's our x1, y1. What about t equals 1? So by modifying the value of the parameter, we can come up with a set of coordinates, x and y, simply by changing the value of t. So if we let t equal 1, 2 times 1 is 2 plus 3 is 3, and y is equal to, so 5 times 1 is 5, minus 3 is equal to 2. So we could use the 2-point formula for gradient, so that's y2 minus y1 over x2 minus x1, and we can find the gradient that way. So m is equal to y2 minus y1 over x2 minus x1. So our y2 minus y1, so we've got 2 minus minus 3 over 3 minus 1, and we end up with 5 over 2. And that makes sense, doesn't it, from the set of parametric equations shown. And of course, we can then choose one of those 2 points. We have the gradient. We can then use the point gradient formula. So y minus y1 is equal to m outside of x minus x1. And we can choose any point we like. So I could use 3, 2. So I'm just running out of space there. So y minus y1, so that's y minus 2, is equal to 5 over 2, that's the gradient we just found, x minus x1, so x minus 3. And we could multiply out the 2 and sort of multiply everything by 2, eliminating the fraction, and we can expand it and then convert it into the form y equals mx plus c. I'll leave you to do that. However, I'm going to rub this all out and I'm going to convert this set of parametric equations into Cartesian form first. And let's see how we're going to do that. Okay. Now what I'm going to do is I'm going to solve this simultaneously. So I'm going to use a slightly different tactic to what I've done in the previous videos that I've done on this topic. So what I'm going to do is I'm going to eliminate the t by using the elimination method. So I'm going to take equation number 1 and I'm going to multiply that equation by 5. And equation number 2, I'm going to multiply that entire equation by 2. So we end up with 2 equations. So we end up with 5x is equal to 10t plus 5. And let's call that equation number 3. And in the second equation we have 2y is equal to 10t minus 6. And let's call that equation number 4. Now if we subtract equation 4 from equation 3, we'll eliminate the 10t term. Okay, so subtracting 4 from 3, so 3 minus 4, it doesn't really matter which order. Okay, so you're going to have 5x minus 2y is equal to 5 minus minus 6, because the 10t's really just cancel out because one's being subtracted from the other. So you have 5x minus 2y is equal to 11. Okay, if you want to make y the subject of the formula, okay, so we just move everything over the other side. So I'll just do it in a couple of steps. So negative 2y is equal to negative 5x plus 11. And dividing everything by negative 2, we have y is equal to 5 over 2x minus 11 on 2. Okay, and if you recall, remember that example we did where we created two coordinates from choosing two values of t, and we ended up with a gradient of 5 over 2. So you can see that by converting this set of parametric equations into Cartesian form, we obtain the same answer for the gradient. And as a bonus, we also have our y-intercept as well, which is negative 11 on 2. Thank you very much for watching.